Alright, so section 4.1, this is probably one of my favorite sections to talk about. So what this is going to involve is looking at the correlation between two numerical variables. So what we want to look at is if we can see a perceived relationship between two things. So the first thing we're going to talk about is a scatter plot and how do we visualize this relationship. So what a scatter plot is going to be is we are going to take two numerical data sets, which are going to be stacked. So for example, if we look at this here, what this is saying is that we have a leopard gecko that is 20 centimeters long and weighs 45 grams. So if we want to see if there's a relationship between the length of a leopard gecko and how much it weighs, we can do that using a scatter plot. So let's go ahead and start plotting these points. So these points are going to plot just like they would on an XY plane or in any other math class. So the length is going to be our X and our weight is going to be our Y. So for the first one, which is 20 centimeters and 45 grams, that would be right here. 2250, that would be the point right here. 2353 would be up here. 2662 would be here, there, 2558, be somewhere about there. Alright, 2248 would be just below this one, and 2763 would be right here. So even though we don't have a lot of data points, we can see that there's a trend going on here. And what that trend is that as the length increases, we can see that so does the weight. Now one thing that we're going to be interested in when we're looking at these graphs are a couple of things. One thing is going to be the shape. So if you kind of blur your eyes, like what kind of shape do all of these dots make together? The other one is how close are the dots to each other? What that's going to give you is an idea of the variation. So here, if we look at the leopard geckos that are length 22, well, that doesn't mean they're all going to be the same weight. So just because a leopard gecko is 22 centimeters long doesn't mean it has a designated weight. So here we see that one leopard gecko weighs 48 grams while another weighs 50. So that's going to give us an idea of how good is length at really determining the weight. I mean, if they're 2 grams off, I think that's not too bad, but what if they're like 20 grams off? Then maybe I don't want to use the length to determine the weight. Maybe there's a better way to estimate it. Alright, so let's talk about some of the vocabulary that comes with scatter plots. So one that we're going to have is trend. Okay, the next one after that is going to be strength and shape. So strength is going to be talking about how much variation we see on the graph. This is actually going to get a numerical connotation to it a little bit later, but right now we're going to use words like strong, weak, or so-so. First we're going to talk about trend. So a trend is going to be positive if as X increases, Y also increases. So if we were to draw some dots, like so, what we can see is that as one goes up, the other goes up. So as X increases, then Y increases. And if you go backwards, then as X decreases, Y also decreases. Now a negative trend would be that as X increases, our Y decreases. So as X increases or goes up, then our Y decreases. As well, if you go backwards, as Y decreases, then Y increases. So just a couple of things about this. If you're looking at a positive trend, one of the positive trends that we could see would be things like as your height increases, so does your weight. Okay? A negative trend could be the amount of money that you make increases, so the amount of debt that you have decreases. So, for positive trend, one thing that I want to point out to you is that if this was a straight line or linear equation, this would have a positive slope. And here, if this was a straight line equation that we're looking at, this one would have a negative slope. This is going to come in handy a little bit later. Now, when we're talking about trends, they don't have to be straight lines, and they don't have to be just increasing or decreasing. So, for example, if we look at the scatter plot on the left, which is going to be time and age, what this is going to have is this is going to have no trend. So your age doesn't determine how long you spend in traffic. So this would be a no trend. But we have to be careful, because just because we don't have a positive or negative trend doesn't mean there's no trend. So if we look at B, which is talking about the sea levels, so this would be the ocean going up under sea level. So what this would be saying is we have a changing trend. So it goes from negative to positive, so this would be a changing trend. So for fun, what I would like you guys to do is I'd like you to try to think of two variables that have no trend and that have a changing trend. Okay? You don't have to submit it to me, although I am always interested, but it is a good thing to think about. Now, when we talk about the strength in an association, okay, we are going to have what kind of strength when we have a large amount of scatter in the scatter plot? Well, what that is going to be is that is going to be a weak association. Whereas if we have very little variation, then that means that these two things are strong. That means you can use one very easily to predict the other. So, as an example, if I wanted to predict your weight using your height, well, I could, but see that there's a lot of vertical variation. So if we look at this graph, if I look at somebody who's 70 inches tall, well, their weight could range anywhere from, it looks like about 120 pounds to 260 pounds. That's a lot of variation. However, if I look at using your waist measurement instead of your weight, you can see that these are clumped together and I don't have as much vertical variation. So, for example, let's say that I wanted to look at somebody who has a waist of 35 inches. Well, the difference would be between 140 to 200, and that's a much smaller difference. It's only a 60-pound give or take, whereas over here, when I'm looking at height, 120 to 260, that's 140 pounds. That's over twice the difference between a smaller individual. So what we would say is we would say that this one had a stronger correlation and this one would have a weaker correlation. Again, we're going to get an actual numerical value and a nice tight rule to go along with these. Now, when we're identifying the shape, what we can do is we can put them into two groups. So you either say that the shape of the graph looks linear, which means it's a straight line, which means that it's either always going to be increasing, which means as a positive association or a positive slope, or decreasing. Anything that isn't a straight line in this class, we're just going to say it's nonlinear. So this could look exponential, it could look like a parabola, a cubic, basically anything that isn't a straight line. Now, if you're going to write a clear description of association, there's 4 things that you need. The first one is going to be trend. Then you need to describe the strength, then the shape, not necessarily in that order, And the last thing you need is, very important, statistics, math, all of that doesn't mean a thing if you don't have that context. So you have to be able to tell people, hey, I saw this, this is what it means in the context of the problem. So if we look down here, we're going to have two examples where we're given a setup and we're asked to describe the relationship using these four things. So go ahead and pause the video and take a whack at doing this on your own. And after you unpause this, I will go through and do these. Okay, so if we look at the first one, I'm going to read through the problem first. So what this is that they're using the age of propellant. Okay, so a rocket motor is manufactured by bonding an igniter propellant and a sustainer propellant together inside a metal housing. So you can think of the age of the propellant as like the age of glue, basically. The shear strength of the bond between the two types is an important quality characteristic. So what we're looking at is how does the age of the glue affect the shear strength of the object. So if we look at the scatter plot, what I see is that as the age of the propellant increases, the shear strength is going to decrease. As well, if I draw a line through most of my data, or if I try to draw a shape around most of my data, I see that it makes a straight line. Also, because it has a basic shape to it, I would say that the strength is relatively strong. So as long as you can see kind of a basic shape or an outline of a shape, that means that there's a strong association. So when I'm summarizing this, I'm just going to do it as a full sentence. So I would say the correlation between propellant and strength shows a strong linear negative relationship. Another way that you could word this is you could say, as age of the propellant increases, the strength decreases strongly in a linear way. So that's two ways that you could answer this question, and those would be totally fine. Okay, let's look at the next one. So, a research engineer is investigating the use of windmills to generate electricity. He has collected the data on the DC output from the windmills and the corresponding wind velocity. The data is plotted below in a scatter plot. So, if we look at this, what we can see is that as the DC output has been increased, the wind velocity increased. And if I draw a shape around these dots, what I can see is that I don't really get a straight line. Actually, this looks more like half a parabola, or some of you might have said exponential, which is great. You can just say it's non-linear because it's not a straight line. Also, similar to the last example, I don't see a whole lot of scatter in these guys. I do see a very distinctive shape. So, again, what I would say for this one is I would say that there is a positive, nonlinear, strong trend between DC output. So one way that we could put this is as wind velocity increases, DC output also increases in a strong nonlinear way. Great, so in the next section we're actually going to be able to put numbers to strength, and we're also going to be able to put a formula to finding a line that's going to describe the relationship between our data.